first and most reliable way to fly is to let imagination soar. In the beginning, flying was something for adventurers to do on a dare. Dreamers, pioneers, aviators and resourceful scientists set a course for air and spaceflight far into the future. Passion, unique discoveries and awe-inspiring inventions set the standard for the vision of flight. Preparing to make that first big leap required the acquisition of a bit of avian know-how. It all began with the bold quest of an engineer from Berlin, Otto Lilienthal. Lilienthal took to the air with hang gliders he made himself. The flights were short.
Lilienthal wollte herausfinden, was ist der eigentliche Grund.
Lilienthal wanted to find out exactly how birds flew, so he watched them.
Durch Naturbeobachtung gemacht, also ein wissenschaftlicher Ansatz.
Using a scientific approach, he augmented the observations with his own experiments. That's what predestined him to become the first researcher to explain how propulsion worked. Until then, it was a real riddle.
Erklären zu können, das war vorher ein großes Geheimnis.
Experimentation was ascending. Lilienthal studied the characteristics of birds' wings, such as storks, for example. Observation led him to make a key discovery. Storks' gently arched wings produce the lowest resistance and the greatest lift. Lilienthal was laying the groundwork for new invention. Flight was merely a step away. Taking off into the wind worked, just as it did for birds. In 1891, Lilienthal flew 15 meters. Soon he was making flights of up to 300 meters, until August the 9th, 1896, when he fell to his death, probably trying to best his own record. In 1900, Imperial Germany is bustling. A technologically advanced great power, the tap of the telegraph revolutionizes communication and sets the beat for Germany's spin through the exciting days of the avant-garde. Rail lines link one corner of the country to the other. And the gramophone is popular. In the coming years, 23 Nobel Prizes are awarded to German scientists. Car racing becomes all the rage. And Count Ferdinand von Zeppelin is soaring high above Lake Constance. The conquest of the skies is starting. In 1907, the Model Airship Testing Institute is set up at Göttingen. The first institution devoted to avian research is equipped with a closed wind tunnel, designed to investigate the problems of flight. An electrically powered fan is used to generate a current of air inside a large tube. Motors and propellers are designed and specially made for the unique piece of testing equipment. The wind tunnel is the first of its kind and marks a milestone in the history of this type of testing technology. The first experiments are carried out under conditions of controlled airflow.
At the time, airships rather than planes were really the passion of flight enthusiasts. At the turn of the century, Zeppelins were already a recognized means of air transport. But there was little knowledge of aerodynamic laws. What was the shape that would optimize the movement of an airship through the air?
The real work begins with the first measurements, which are taken after a turbulence-free airflow, suitable for experimental purposes, is successfully generated in the tunnel. Among the data recorded are drag, airflows, and pressure distribution. The optimal shape for an aircraft remains a mystery. Airship designer August von Parseval is the first to commission the Institute to investigate and develop ways to improve the airworthiness of his craft. Parseval draws attention by making experimental flights that are longer than 1 hour. On the eve of World War I, Germany leads the world in the development of dirigibles.
Luftschiffe vor 1910, die waren ganz unterschiedlich.
Before 1910, airships were built every which way. Some were pointed at the prow, others at the stern. Some looked like cigars. There were long ones, short ones. Every possible shape and size were represented. After the data were gathered and assessed at Göttingen, all the world's airships looked the same. They were slightly rounded at the front and gently pointed at the rear.
Sanft zugespitzt.
Balloon races become fashionable. The controversy over whether something heavier than air will ever fly begins in earnest. The dispute does nothing to dampen spirits. Aims remain high.
France had a head start when it came to aviation research. Germany had to catch up and managed it with the help of people like Count Zeppelin. So heady was his reputation that it was lighter than air. Based on this and a wealth of experience, he became the person who set the tone for the future and can be credited with putting the study of flight on an institutionalized scientific footing.
Motorized flight is not far off. After thoroughly studying Lilienthal's work, two American designers, the Wright brothers, become the first to make a motorized flight in 1903 in a craft that is heavier than air. Many are willing to risk life, limb, and becoming a laughingstock in experiment after experiment. Often their contraptions do everything but produce the desired result. The idea of flight sends the fancies of dreamers, inventors, and serious aficionados soaring, leading many of them to be scorned by others as visionary lunatics. In 1904, the hydrodynamic engineer Ludwig Prandtl makes a startling discovery that revolutionizes the up-and-coming new science of aerodynamics. He describes the boundary layer, where all airflow changes occur. The discovery brings Prandtl recognition from all over the world, including Russia and later the US. Then, in 1909, Prandtl is made the world's first professor of airship flight. His scientific writings, such as the wing or lifting line theory, create a huge stir and become one of the key cornerstones of aerodynamics.
The boundary layer is in immediate contact with an object surface. The greater the distance from the surface, the more the layer conforms to its surroundings. Considered mathematically, the boundary layer is a bit of a simplification. Ludwig Prandtl applied this trick in 1904 to calculate and describe numerically currents along the surfaces of different objects.
Scientists of aerodynamics meet at the world's first aeronautics congress in Göttingen in 1911. It's one of the first times that the benefits science could have for aviation are discussed in an open scientific forum. Aerodynamics and the mechanics of flight are addressed. In the same year, a student of Prandtl's, Theodor von Karman, publishes his theory of vortex streets, the swirling motion of gases behind an object after they've moved over it. Air shows are the latest diversion. To get their thrills, Berlin residents flock to the quiet suburb of Johannisthal on Sundays. In 1909, flyers, the obsessed and tearaways give excited spectators the show they want to see in the skies above one of the first German airfields to feature motorized planes. Even the Wright brothers are buzzing Europe. Crown Prince Wilhelm, here speaking to Orville Wright, is impressed. On Sundays, more than 500,000 viewers attend. Aviation pioneers began to pit their homemade machines against each other. Fortunes in prizes go to the fastest flyers. The Imperial Court and Industry offers stakes as high as 40,000 marks in gold.
During the early years of flight, progress came as a result of trial and error. You built a plane knowing it needed an undercarriage and two wings. But beyond that, everything, considerations like how fixed the wings should be or what would create the least drag, was a big grey area, nebulous and unknown. Everyone was tinkering around in their workshops and sheds. Mechanical skill became the means to pursue the dream of building a flying machine, but without any scientific qualifications. They simply made contraptions and then tried to see if they would fly.
Clattering flying machines have their charms. French, British and American inventors stole the show from the German aviators to begin with. The spirit of flying competitions was still sporting, but only just.
Early on, there were n number of experiments, meaning there were countless. There were planes with the engine in back, some had 5, 6 or 7 wings. They tried everything. The times were creative, and nobody knew exactly where it was all heading. Anyone was free to experiment, but the risks were high. Attempts to discover if their ideas really worked cost many early airplane builders their lives.
Aviation pioneer Hans Grade moves Germany back into the spotlight by winning the Lanz Aviation Prize in 1909. The triumph helps the country regain ground Germany needs to make up. To win, Grade had to fly a horizontal figure of 8, some 2.5 kilometers in length. All parts of the aircraft had to be from Germany, and the plane's builder and pilot had to be German as well.
The technological leaps were spurred by ready cash. Germany had registered that aircraft were being built in all the neighboring countries. Even France, known to some as the hereditary enemy, had already built many planes. But us, we didn't have a thing. It's a simple technical fact, understood by every engineer and scientist. If the money's there, then research will progress. Soon there was discussion about whether the entire development shouldn't take place under the auspices of a larger scientific organization. A scientific institution had to be set up to address these questions, which had previously been tackled by in-flight experiments.
The German Aviation Testing Facility, or DVL, is set up with the signing of a certificate in 1912. The compound at Adlershof becomes the Aviation Research Center of the nearby German imperial capital Berlin.
In 1912, they began to build research institutes at breakneck speed. Not just hangars and airfields, but wind tunnels and testing rigs for engines with all levels of horsepower. A large concentration of research hardware and personnel were located here. That did nothing to impede synergies with other research establishments, while it remained a place where one could work relatively independently.
A veteran aviator and airship pilot, Major Georg von Tschudi, becomes the director of the nearby airfield at Johannisthal. The landscape of the Mark becomes a home for departments engaged in researching the physics and technology of flight, in addition to the site for a number of test rigs. Engine overheating plagued the early years of flight. Some of the best-known aircraft makers of the time settle near the gates of the DVL compound to improve their craft through systematic application of scientific research and establish a link between industry and research. The military expresses its interest as well. War breaks out in August 1914. Planes become weapons for generals to deploy. More maneuverable, faster, and with a far better vantage point, the aircraft replaces the cavalry as a reconnaissance tool. Contemporary heroes are Immelmann, Bölke and Udet. The day of the elite fighter pilot dawns. conquering the skies is taken literally. Research is now done in the name of war. Fighter production begins and the first one-seater planes delivered to the front. Men like Manfred von Richthofen, the Red Baron, fight their way to fame and fortune. The age of the flying ace has arrived. Bombers and gunships are built and increasingly deployed against strategic targets. New plans are made to build a larger research compound equipped with bigger wind tunnels. In 1916, a model testing establishment for aerodynamics, the MVA, is built in Göttingen.
Im Ersten Weltkrieg
During World War I, military resources were used to drastically enlarge the research establishment at Göttingen.
mit Mitteln des Militärs und ein
A much larger wind tunnel was built there, and in both the small and the new, larger tunnel, a series of experiments were carried out on wing cross-sections, airfoils.
Vielzahl von Tragflügelprofilen im Windkanal vermessen.
Seen from an empirical standpoint, this was the start of the scientific study of aerodynamics.
Aerodynamik.
The new tunnel is state-of-the-art, a model for similar testing facilities the world over. It produces wind speeds of up to 180 kilometers an hour and lends its name to all subsequent wind tunnels like it, the Göttingen type.
Im Göttinger Windkanal
A number of airfoils designed and developed by different aircraft makers were tested in the Göttingen wind tunnel.
Diese Flügelprofile wurden in anonymisierter Form
Results for the different airfoils were published in anonymous technical reports, so that one manufacturer wouldn't know what another competitor had developed.
der jeweiligen Flugzeughersteller nicht erfuhren, was ihre jeweiligen Konkurrenten so auf Lager haben. In Göttingen hat man diese
In Göttingen, they simply numbered the airfoils and tested them, and some of their own different designs, sometimes varying them slightly.
variiert und
They then recorded the aerodynamic data.
festgehalten.
During the First World War, the data were stored in files that were either secret or accessible solely to the manufacturer that had created the design.
Und Forschern zugänglich waren, veröffentlicht.
Wing templates drawn up at Göttingen become the industry standard for decades to come. Anyone, anywhere in the world who wants to build an aircraft uses them as a guide. The name Göttingen goes down in aviation research history. Testing wings by loading them with sand sacks and 42 troops leads to the development of a new branch of research, aeroelasticity. A model train pulls a test rig in the Göttingen wind tunnel. A life-size version of the experiment is conducted later, south of Berlin, on the military railway between Zossen and Jüterbog. Engine and propeller test rigs run on rails. Assessments are conducted under outdoor conditions, similar to those faced by an aircraft in flight. Aerodynamic shaping of wings, fuselage, propeller and other parts of the plane, certain types of engine are the scientific fruits of World War I.
Wenn man gleichzeitig sieht,
If you consider the change in the look of planes between 1914 and 1918, it really becomes clear that a major leap had taken place. 1918 vintage planes flew considerably higher, were faster, and could carry greater loads, bombs in this case. By the end of the war, plane designs and technologies had, like a good wine, matured and improved with age.
Fokker builds the first one-seater monoplane fighter, and Hugo Junkers makes the prevalence of wood as a material for building aircraft a thing of the past when he builds the J-1, the world's first metal plane. But aviation progress did nothing to avert Germany's defeat in the war. The armistice was signed on November the 11th, 1918. The 1920s roar into life as Europe recovers from the war. Everything is new, exciting and ever so modern. It seems the whole world is a big dance hall. But in the Treaty of Versailles, the winners of the war hand Germany the bill for its earlier aggression. The country's aircraft are scrapped. What the Allied forces, Britain, France and the US, don't need is decommissioned, dismantled and destroyed. Even aircraft engines end up on the scrap heap. Soon the hangars are empty. German aircraft are never again to be used to wage war. Competitive German plane makers are closed down. But the setback becomes a turning point. Now experiments in Göttingen are focused on completely different models. The streamlined Rumpler Tropfenauto is tested in 1921. Though it's more than 6 decades ahead of its time, the low wind resistance multi-passenger car is never mass-produced. In 1923, the Research Institute only has a staff of 15. A model of an express train is also subjected to the artificial stream of air, and drag measurements are taken for Daimler racing cars clad in streamlined hulls. The cars later reach speeds of 190 km per hour. The wind tunnel is also used to prepare initial designs and prototypes for gliders. The aviators have found a loophole in the restrictions placed on them by the Allies. The Treaty of Versailles mentions motorized flight only.
Wir dürfen nicht mehr fliegen. Ja,
What do you mean we're grounded? Impossible. The ban on motorized flight in the Versailles Treaty led to the start of a great new development in aviation, the glider. Aficionados and experts met on the Wasserkuppe. Looking at these contraptions made of nothing more than wooden spars and stretched cloth, it's really amazing that they actually flew some 200 to 300 meters and stayed up in the air for a minute or two. Sometimes banning an activity can have unforeseen effects that have little to do with the ban's original purpose. While one activity is stamped out, something else springs up in its place.
Gliding is the sole option left to Germany's aviators. But by 1920, they are already holding the first gliding competitions in the skies above the highest peak in the Rhön Mountains, the Wasserkuppe.
The project in this case was to develop aerodynamic specifications for gliders. A scientific foundation for soaring was to be laid that would address meteorology in particular, and the knowledge of air currents, which are both key to gliding for long distances. This clearly demonstrates how gliding became a vital component of aviation research.
A short time later, German pilots are able to resume powered flight. Mail and passenger services are among the first to take off. The first airlines are opened. Dornier builds its famous flying boat, the Wal or Whale. The plane makes history when in 1926 it becomes the first aircraft to cross the South Atlantic. The Junkers F-13 becomes the first passenger aircraft in the world to be built out of metal. With it as a workhorse, the newly established German airline Lufthansa gains preeminence in the skies. An unintended consequence of the Versailles Treaty is that Germany is able to successfully build planes that are aerodynamically superior, because they may only be powered by relatively weak motors. In 1924, construction begins on the new building at the Kaiser Wilhelm Institute in Göttingen. Since 1920, the MVA has been known as the Aerodynamic Testing Facility, or AVA. Plans are unveiled in 1928 for another wind tunnel. The measurement area is to be 4.5 by 7 meters in size, one of the biggest of its kind at the time. A few years later, the first specialized wind tunnels, able to generate wind speeds in excess of 900 kilometers an hour, are built. Adlershof has been equipped with additional motor and propeller testing rigs by the end of the 1920s. The facilities are also used to assess the airworthiness of aircraft in a sort of standardized MOT for planes. Dressed in an elegant suit, Leslie Irving came all the way from Buffalo, New York to test his airchute or freefall parachute. After tests at Johannisthal Airfield, the new invention was certified safe in 1929. During World War I, flyers rejected parachutes as being beneath their honor. But by 1930, they were being used by more than 40 air forces. By September 1930, a group of imaginative, innovative individuals cause a commotion by taking aim at the stars. A group of pioneering, daredevil, enthusiastic hobbyists begin carrying out dangerous combustion experiments with liquid-fueled rockets. Ranging from visionary to crackpot, they're united in the hope that they will soon send rockets into space. The former parade ground in Berlin's Tegel district becomes the proving ground for these completely unpredictable flying objects.
The idea of interplanetary spaceflight wasn't just being bandied about, it was extraordinarily popular. There were big fan clubs with large memberships and comprehensive literature that from a cosmic standpoint was actually very far-reaching. Flights to Mars were discussed, as were types of satellites that we can't even now imagine. They were visionaries.
They fire more than 100 rockets into the skies above Berlin. Known sardonically to some as the Tegel Fools, these hobbyists are setting the foundations for space travel.
Rockets were an ersatz for the loss of national and government power. Leading German scientists were thinking about spaceflight. The title of Hermann Obert's trailblazing work showed where things were headed: the rocket into interplanetary space. There were loads of rocketry clubs, amateur rocket builders associations. Rocket mania was widespread among the general population. Fritz Lang's films were right on target. Rockets were the thing in Germany in the 1920s. Opel's rocket car was another example. This enthusiasm was something scientists could build on.
People everywhere seemed crazy about rockets, not only in the skies over Brandenburg, but on the road. Even one of Germany's greatest automobile makers of the time, Fritz von Opel, wants a piece of the action. The physicist and spaceflight pioneer Max Valier conceives of a car capable of explosive speeds, and Opel is to drive it. Forget the engine, the popular Rak 2 is powered by 24 solid rockets. 3,000 excited Berlin residents come out to see a test drive. The show is short and sweet. The trip takes 2 minutes, with the Rak 2 reaching speeds of 200 kilometers per hour. There are demands to step it up a notch. Designers produce a rocket-powered car on rails, but they daren't ask anyone, not even Fritz von Opel, to drive it. A cat is placed at the helm. Some 300 kilograms of dynamite go off with a big bang. For the record, the comforting note says that the cat survived with minor injuries. One young Berlin rocket man is going to make a name for himself in the future. Werner von Braun's career begins when he takes a job at an experimental site in Kummersdorf, south of Berlin. It's 1933, and preparations for the military use of rockets is getting underway. Commissioned by the Office of Military Armaments, the task was to test rocket engines for use in missiles. Air travel gets a majestic boost when an aircraft, the Dornier Doe X, becomes the pride of a country crazy about flight. The world's largest aircraft, the colossal plane seats 160 passengers. In an unparalleled triumph, the technical wonder arrived in New York City from Germany on August 27, 1931. The Junkers W-33 also rose to fame when it crossed the Atlantic. Some say it's flight's golden age, highlighted by many new designs and developments, such as the Junkers G-38. Germany is again the mecca of aviation research. Experiments are promoted by the state, but science retains its independence. An enormous concrete egg is built in Adlershof. It's a vertical wind tunnel to be used to assess what forces do to an aircraft in a spin. It's also to help determine what causes planes to crash for seemingly no reason.
These were tough times for aviation. The technical possibilities of flight went far beyond human capabilities to control them. So it was decided to set up scientific establishments where it would be possible to investigate scenarios under controlled laboratory conditions before disaster struck. That's why they built the vertical wind tunnel, to learn more about the dangers of the flat spin.
The ground is rushing up on a free-falling plane. DVL test pilot Richard Perlia is in the cockpit. It's up to him to experience the reality of the dangers of a flat spin.
I was really fascinated by flat spins. You usually couldn't get out of them. I flew a Messerschmitt Me 31 with low-slung wings. It was filled with lead pellets for the test. When I reached 3,500 meters, I was to take my foot off the gas and pull the stick back as far as it could go. That really went against my instincts. Then I was supposed to hit the rudder. I always sat on the left, even in the two-seaters. The plane went into a real flat spin. 18 spins were planned, but after 11 full turns I was getting a little dizzy. So I looked down and picked out houses and a church tower. Then I started to count, 11, 12, 13, up to 18. That was it. I was supposed to pull out hard. If I'd moved the stick the wrong way, I wouldn't be sitting here now. The worst thing was that the stick kept jumping around like an electric mixer. It was as if the rudder was no longer there. That's a flat spin for you.
Progress is also made in the development of rotor-driven aircraft. On June 26, 1936, the world's first fully controllable helicopter, the Focke-Wulf FW-61, makes its maiden flight. On the fourth try, it remains airborne for 16 minutes. Buildings are going up everywhere, in Adlershof, in Göttingen, and starting in 1936 in Braunschweig, where the German Aviation Research Establishment, DFL, is being set up. The wind tunnels here have awe-inspiring dimensions. Some are up to 14 meters in diameter. Wings and even entire full-scale aircraft can be tested here. In 1935, Germany unilaterally withdraws from the Treaty of Versailles. During this period, nearly 30 million Reichsmark flow into research. Scientists are to draw up new specifications for larger planes with more powerful engines. High-speed and high-altitude flights are on the agenda. Germany has some of the most modern aviation research facilities in the world at its disposal.
The big wind tunnel was for slower planes. During the years it was being built, it was planned to generate air speeds of up to 65 meters per second. That's a little over 200 kilometers per hour. Those were normal flying conditions for passenger and transport planes. And the tunnel's large diameter, 14.5 meters at its maximum, made it suitable for testing life-sized models, which produced excellent results.
Research gets underway on a large scale. By the end of the 1930s, several thousand people are employed in German aviation research. Europe is getting smaller. A flight to Rome takes just 10 hours. The Junkers Ju-52 becomes the epitome of a mass-produced aircraft. At 5,000 planes, it's the most frequently built plane of its time. Trademarks like metal construction and low-slung wings make it one of the most modern, robust and high-performance aircraft of its time. Scientists in Göttingen get involved in the study of a mysterious phenomenon known as flutter, which destroys wings and parts of a plane's stabilizers, elevators, and rudders at high speeds. A U-288 is put to the test in Braunschweig and a He-219 in Göttingen. The result is the discovery of new ways to prevent flutter that are still applied in building aircraft today. Test flights for Project X get underway in 1938. The revolutionary new plane is propelled by a rocket. After a series of setbacks, the first rocket-powered Messerschmitt 163s take off in 1941. The fighter's design incorporates aerodynamic wings that are a decade before their time. They were developed on gliders being flown while Germany was still subject to the restrictions set in Versailles. At that time, the plane's speed at takeoff was unimaginable. The Mir 163 is what's called a flying wing aircraft. It's capable of flying almost as fast as the speed of sound. In Germany, designers like Lippisch and Horten favoured flying wing aircraft, or planes without a fuselage. Their visionary drafts date back to their gliding days. The National Socialists have been in power since 1933. Military research has top priority. A model of the first German aircraft carrier, the Graf Zeppelin, is tested in one of the wind tunnels at Adlershof. Poorly designed, the vessel is never deployed in a military action. More new planes are in the sky. Flight gathers new impetus. The Mir 262 is the first operational turbojet fighter aircraft. By 1938, Hans von Orhein has already developed the world's first turbojet engine. A German scientist, speaking at the Volta Congress in Rome in 1935, introduces a revolutionary theory concerning lift when flying at speeds greater than that of sound.
A German professor from Göttingen, Adolf Busemann, attended the Congress. But his presentation drew little attention, even though he told his colleagues how to design a plane capable of flying at supersonic speeds. Wings attached to the fuselage at right angles had to be scrapped. Instead, the wings had to be angled back and became known as swept wings.
Aircraft wings must be redefined. The theory represents an aerodynamic breakthrough that is still being applied today. Swept wing designs for high-speed aircraft are tested in the wind tunnel, and patents are filed for ground-adjustable wing sweep, which was invented in 1939. Science is getting ahead of its time. The idea of modifying wing sweep comes too late for the first generation of turbojets, and too early for the second generation.
It soon became clear that there was no way to outgun the three great economic superpowers, the Soviet Union, Britain, and the United States. We figured we had only one chance, and that was to use quality to make up for our quantitative deficits.
The search for a means to counter Allied air superiority begins. Engineers develop the Fiesler 103, an unmanned flying bomb, steered by a guidance system. The world's first cruise missile is called the V-1, with V standing for Vengeance Weapon. The missile brought destruction and suffering to many. Different generations of guided missiles are tested in the wind tunnels. Between 1936 and 1945, Germany becomes a centre for the development of air and space flight technologies that continue to impact both civilian and military aviation well into the second half of the 20th century. One of the most ambitious projects at this time is the development of a ballistic missile, the A-4. The rocket is 14 meters tall, weighs 14 tons, and can generate 25 tons of thrust. To promote the project, the Third Reich's most expensive and elaborate, a top-secret program is initiated at Peenemünde on the Baltic coast. A previously unimagined research facility and rocket factory are set up. More than 6,000 scientists, engineers, and 13,000 support staff begin working to achieve the dream of putting a rocket into space. But at the same time, they're building a new weapon that will fundamentally change the way wars are waged in the 20th century and beyond. Breakthroughs are made in the key technologies of electronics, radio, guidance, and stabilization. The A4's engine is 17 times more powerful than those developed before it.
They built enormous research complexes that had thousands of staff members. You could certainly say it was big science. For the sake of efficiency and to carry out all the tasks set them by the aviation industry, 3 8-hour shifts kept the place running round the clock. In the gargantuan weapons-building complex that Germany had become in the 1930s and 1940s, the demand for aircraft and materials tests was huge. The day of big science had arrived.
Progress is also being made again in the wind tunnel. Air speeds of Mach 4.4 have been generated to set a new world record. In 1941, an A4 prototype is set up in a test rig. Werner von Braun combines scientific excellence with diplomatic skill when dealing with politicians. But he's also an opportunist. Sending rockets to the planets is a dream. The V-2 missile some describe as a wonder weapon is a necessary means to achieve that end. Von Braun never expresses ethical reservations, even when prisoners of war are used to build the missiles. The military testing facility is a highly efficient research center. The key to its success is everything under one roof. The close ties between the state, research and industry become an example for major scientific projects in the future.
Today, you can objectively say that German research and development focused not only on building rockets, but on establishing the scientific principles of spaceflight, from aerodynamics to guidance. By thinking all the data through, Germany had already developed more advanced concepts. In America and the Soviet Union, rockets were being built, but only on a selective ad hoc basis. Until 1945, only Germany conducted a consistent aviation technology development program. You can say that at this time, we were really far ahead of all the others. You can emphasize that without being presumptuous. It's a fact on which today's experts from the East and the West agree.
After 7 years of work, the first A4 rocket is successfully launched on October 3, 1942 at Peenemünde. It's the first time engineers have been able to send a rocket some 100 kilometers into space. The space age is dawning. But Peenemünde is also a symbol for the darker side of science. Some 30,000 prisoners die building the rockets, and 5,000 more are killed when they're deployed. Germany's misuse of the fruits of its fascination with flight comes back with a vengeance. But the country lives to fly another day. A decade later, Germany returns to the echelons of international air and space research. A Century in Flight. Part 2 of this documentary addresses the years from 1945 until the present.